Hello everyone. For this session, I'm going to show you how to derive the formula for effective resistance when the resistors are connected in series or in parallel. Now let us study the circuit diagram on the left side first. On the left side, both resistors are connected in series. I'm now sure to derive the formula for the effective resistance connected in series. Now let the EMF of the battery be Vs and the potential difference across first resistor to be V1 and the second resistor to be V2. Now let the first resistor be R1 and the second one be R2. Now since R1 and R2 are connected in series, and we know from the earlier video that the current through both resistors connected in series is constant. Now let this current be I. And from another video, we also learned that the potential difference of the across the resistors connected in series, the total potential difference is equal to the EMF of the battery. And that means I have Vs equals V1 plus V2. And using V equals IR approach, V1 I R1 plus V2 I R2. And how about Vs? So we just let the effective resistance be Rs, since S can be used to represent series connection. So we just let I Rs. So Rs will be referred to the effective resistance when resistors are connected in series. And from here we know we can cancel out I, and we are left with Rs equals R1 plus R2. So Rs equals R1 plus R2 refers to the effective resistance when resistors are connected in series. In other words, we just add up the resistance. How about when resistors are connected in parallel? You let the EMF on the circuit on the right be Vp, since P can represent parallel. And you let the potential difference across one of the resistors be V3 and the other one be V4. And the current supplied by the battery, we let it be IP. And when IP reaches the junction, it splits into two. We let this be I4 and I3. So we let the resistor, the resistor which potential difference is V3 be R3 and the other be R4. Now, we know that IP equals I3 plus I4. And from V equals IR, we know that I equals V over R. So IP will be Vp over Rp. So Rp will refer to the effective resistance across the resistors connected in parallel. And I3 will refer to V3 over R3 plus I4 refer to V4 over R4. And since the two resistors are connected in parallel, we know that V3 equals V4, which is equals to Vp. So we can we can rewrite it as Vp over Rp equals Vp over R3 plus Vp over R4. And we cancel, cancel, cancel. We are left with 1 over Rp equals 1 over R3 plus 1 over R4. And hence, to summarize, this is your second equation and this is your first equation.